Well, welcome back. Thanks for joining me. We're going to discuss the classification of matter in this lesson. So matter is anything you can touch, see, feel, smell. We understand that, but we can categorize it and subcategorize it a little bit. So let's try that. So there'll be a series of questions we can ask in order to answer this. Can the material in front of you be physically separated? And if the answer is yes, then what you have is a mixture. If the answer is no, then what you have is a pure substance. So that's like maybe this is humanity, and then there's man and woman, right? We can subcategorize humanity. Then for mixtures, is the composition uniform? In other words, if I have a big bucket of this stuff, if I reach in and take a handful, and I reach in and take another handful later on, will it look the same? Is the composition uniform? And if the answer is yes, you are dealing with a solution or a homogeneous mixture. Now, a solution doesn't have to be just a liquid. It can be, but you can have two gases. They can make a homogeneous mixture or a solution. Or you could have a solid in a gas, or any other combination of states of matter can produce a solution. A solution simply means it's homogeneous or mixed uniformly and evenly. If our mixture is not mixed uniformly, then we have a heterogeneous mixture. If you have a pure substance, the question we want to ask is, can it chemically be decomposed? In other words, can you do a chemical reaction to break this down into something simpler? If the answer is yes, you can break it down. You are dealing with a compound. If the answer is no, you have an element. So that's pretty good so far, but we can even break it down a little bit further. Heterogeneous mixtures can either be colloids or suspensions. Now, the difference is between a solution, a colloid, and a suspension is particle size. Do you remember, like, there was Goldilocks and the Three Bears, and little Goldilocks went and she found one bed was too hard and one was too soft and one was just right? Well, it turns out that if you think back to when we talked about water, there were those pockets or interstitial spaces in between the water molecules where stuff dissolves. If what you're trying to dissolve is very small, it will fit in that little pocket and you'll form a solution. If what you're trying to fit in that little pocket, what you're trying to dissolve is too large at the molecular level, it will settle to the bottom and it will be called a suspension. If it's big enough that it fits in those pockets, but it's also big enough that you can see with the naked eye, we call it a colloid. And we'll talk more about colloids and suspensions here in a little bit. The main part is know the difference that mixtures and pure substances are different because pure substances cannot be separated by physical means. The only thing you can do is separate out a compound into elements by doing a chemical reaction. Mixtures also can have any composition you want. You can take a little bit of salt and put it in water, or a lot of salt and put it in water. And so heterogeneous and homogeneous mixtures can have variable compositions, variable percentages. Compounds are fixed. They're always the same ratio of the atoms that make it up. Those are some of the differences to learn. So we know that elements and compounds have a definite composition or makeup, and because of this they have definite properties. So an element, we're going to use some Venn diagrams here, only a single kind of atom. Atoms are bonded together, and we'll learn about diatomic and polyatomic. What that means is di, that prefix, means two. So when you find oxygen, it's always two oxygens stuck together, O2. Hydrogen is always two hydrogens, H2. Chlorine is always two Cl, Cl2. And we'll learn there are actually like 7 diatomic elements, always found in pairs. And then there's 2 that they're found in more than that. You know, like when you write a thank you letter, maybe your grandma got you something nice for your birthday, so you didn't want to send a text. You actually wrote a letter. And after you sign love and you put your name, you forgot to thank her for the gift. So you write, what are the two letters you write again? PS. Now, PS refers to postscript, meaning after you've signed your name, what else are you going to write? But for us, it refers to phosphorus and sulfur. Phosphorus and sulfur. Now, I don't know if my pen will work here. Let's see if we can get it to work here. I'm going to write P. Whoa, that's a bad looking P. Let's try an S. All right, well, that's not going to work. Well, I'm going to say I'm done with that because that definitely wasn't going to work the way I wanted there. But if you write a PS and then you put a subscript 4 in front after the P, that means phosphorus comes in groups of 4. And sulfur, if you make the shape of an S and then you keep making the shape of an S, it turns into an 8, doesn't it? Sulfurs come in groups of 8, and phosphorus comes before the sulfur. So phosphorus is P4, sulfur comes in S8. Those are polyatomic elements. So if they're not diatomic, they're not polyatomic, they're monatomic, which means they're just found by themselves. And we'll address that more in the unit on the periodic table. Compounds are 2 or more kinds of atoms. That means different elements bonded together. So you can have hydrogen and oxygen bonded together, and that would be H2O. Or you could have, well, tons and tons of things. I don't want to belabor the point right now. The key is, in a compound, there's different atoms, and they are bonded together. And then mixtures are 2 or more substances that are physically mixed but not bonded together. The difference is, physically mixed is like you're dating somebody, and a compound is like you're married to them, right? There's a bond, okay? It's a stronger bond. And then elements and compounds have a definite makeup and properties because they always have the same composition. And mixtures and compounds have 2 or more different materials combined. So that's how we could look at these element, compound, and mixture with our little Venn diagrams. All right, let's practice identifying substances as elements, compounds, or mixtures. And for some students, this is a difficult task. I hope it's not too difficult. Graphite is what's in the end of your pencil. If you have a number 2 pencil, it has a little bit of clay added, so it's not quite so soft and it doesn't smear all over your hands. But maybe you do art, so you've got a bunch of pencils numbered 0, 1, 2, 3, 4, 5, 6, and 6, when you write with it, you can barely read, and the 0, you touch it and it just smears all over black. Well, that's graphite, the 0. So what is graphite? Well, it's actually an element. It's the element carbon. We'll learn later on there are actually different allotropic forms of carbon. One is called graphite, one is called a diamond, one is called Buckminster fullerene, or buckyballs for short. These are different allotropic forms of the same element. Now, that's another day's discussion, so you can start to see there's a language to chemistry that we'll have to learn, not just the content. So sometimes what makes chemistry a more challenging class is there is a foreign language to learn, there is math to apply, and there's a science class to learn. Now, I love all of those things, so for me this is a lot of fun. I hope it will be for you once you master it. Pepper. Is pepper an element that you can find on the periodic table? Now, perhaps you don't have a periodic table in front of you, but if you look, you're going to be looking for a long time. It is not an element. And if it's not an element, is it a compound? Is there a formula? No, there's not a formula either. And if you look at pepper carefully, it can be dark and light and different sizes, so it's not uniform. It's not a compound. Instead, pepper is a mixture. It's a mixture of large and small little pieces, and it's a heterogeneous mixture. It's not always the same. What about sugar, table sugar? What do you think? Well, sugar actually has a formula. Maybe you remember like C6H12O6 or something like that, right? So sugar is a compound. It has a fixed formula and it's made of different elements bonded together. So it's a compound. All right, what about the next one? Paint. Now I don't care if you have spray paint or you have paint in a can. Doesn't all paint have to be shaken? And why are you shaking it? Hopefully what you said is because the solids, the color, probably settled to the bottom and you want to disperse that evenly throughout the paint. So paint is not an element, it's not a compound, it's a mixture. Now, is it heterogeneous or homogeneous? The fact that you have to stir it should be an indication. Good. It's a heterogeneous mixture. Specifically, it settles out, so it's a suspension. So I could call it a heterogeneous mixture, or I could call it a suspension. Let's compare that to pop. Depending where you are from the country, it's soda, or pop, or soda pop, or just Coke. But it's a mixture, isn't it? It's uniformly mixed. There's carbonation, carbon dioxide gas, with sugar and food coloring and flavor, and it's uniform from your first sip to the last sip. You don't have to shake pop or soda in order for it to be mixed. If you don't have to shake it, it is by definition a homogeneous mixture or a solution. All right, for some of you that was a little bit challenging. With some practice, I think you'll get better at that. Let's talk about some more examples of things. A pure substance. Here I have a picture of some copper wires. Copper is an element. It's composed of identical copper atoms, Cu. Now, maybe you've heard of aluminum foil. You probably use it at home. What element is aluminum foil made from? Aluminum, sure. Now, your grandparents would have maybe called aluminum foil tin foil. Now, tin is actually a different element. Tin has the symbol Sn and weighs a lot more than aluminum. Tin foil was like super thick stuff. Why don't we use tin foil anymore? It's kind of expensive, and so people use aluminum foil and they just throw it away when they're done. Maybe they recycle it. That would be nice. Both aluminum and copper are single elements where there's nothing else combined with them in these forms. Aluminum and copper can both be drawn into a wire. What is that property called? Ductility. Excellent. And if it's ductile, you can make wires out of copper. You can also make them out of aluminum. When we look at telephone poles and we look at the wires on those are made of aluminum. They're not made of copper. Copper weighs too much, and the poles would have to be much too large in order for those to hold up all the wires. So they're actually made of very lightweight aluminum. The same reason we make airplanes out of aluminum. It's lightweight and strong. Here's a pure substance. Obviously that's table salt. Table salt has the formula NaCl, or the name sodium chloride. It is a compound. It always has the same ratio. Compounds are made of two or more elements in a fixed ratio. Table salt happens to be NaCl. The properties of the compound is different from the element that makes it up. Table salt is made from sodium metal and chlorine gas. Sodium metal will explode in water, and chlorine gas will kill you if you inhale it. Yet when you put the two together, it's mighty tasty on those French fries. And if you cook without salt, your food probably doesn't have that much flavor. So compounds have different properties from the elements that they're made from. Now, let me ask you this. Sometimes you go to a restaurant and in the salt shaker, you'll see little pieces of what appear to be rice. What is the purpose of that? I don't know. Well, I do actually. They put uncooked rice in the salt because rice is very hygroscopic. That means it absorbs water readily from the environment. Salt will clump up or cake. If you do a lot of cooking and you shake the salt with maybe a metal lid over boiling water, the salt will clump up all over the surface because salt likes to absorb water. So they actually add an anti-humectant or something to salt so that it doesn't clump up and it flows a little bit better. Go home and look at, while you're home, look at the ingredients in salt. It's not just salt in that shaker. They've added iodine for your thyroid gland and other substances as well. So maybe you've dropped your cell phone in the water, right? Nowadays they're pretty water resistant, waterproof, but in the old days they weren't. And so what you had to do if you did that, if you were fortunate, you would run home and you'd put it in some uncooked rice overnight, open the phone up, and the rice might absorb the water and potentially save your phone. Nowadays they're pretty water resistant and they're pretty much indestructible. So technology's improving, that's for sure. So in this example of sodium chloride, notice I have two elements, sodium and chlorine. Now when you write an element, the first letter is always capitalized, the second letter is always lowercase. And that's how you know you're dealing with just two elements here, because you got capital letter, lowercase, capital letter, lowercase. A pure substance will always obey the law of definite composition, which says that compounds will have a fixed ratio of elements in them. The law of multiple, so for water it's always H2O. For sugar it's always C6H6 or C6H12O6, excuse me. For table salt it's NaCl and so on. Okay. Now the law of multiple proportions says that you can combine elements in more than one way. So you can have water H2O, but you can have hydrogen peroxide H2O2. So the same elements combine in different ratios to form different compounds. But the key is they'll always be in a whole number ratio. You will never get a part of an atom, and that's going to be important in understanding what we think of as atoms, that they can only be rearranged. You can't break off a piece of an atom. You get the whole thing. Well, let's look at this example, talking about elements combining in more than one way. I can take carbon and an oxygen, and I can make carbon monoxide. Remember, that's the silent killer that can fill your home and cause you to die if you have incomplete combustion of a fuel in your home. I could also take carbon plus two oxygens and make carbon dioxide. Both carbon monoxide and carbon dioxide are compounds. They are made of whole atoms in whole numbers, but I've taken the same elements and combined them in more than one way. Again, just demonstrating the law of multiple and definite proportions. Mixtures are going to take two or more different substances. They can be elements, but they don't have to be. They can be an element in a compound, or mixtures, whatever you want. Two different substances, and you put them together. Now the key is they can either be mixed not uniformly, that is unevenly, they would be heterogeneous, or mixed uniformly. The simplest example for this for me to give you is a pizza. If you have a cheese pizza, every bite is pretty much the same. Bread and cheese and sauce. That would be the homogeneous mixture. The heterogeneous mixture would be pizza with the works. One bite you might get anchovies, maybe you don't like them. Another bite you get pepperoni, another bite you get bell peppers and mushrooms. Every bite's a surprise, isn't it? With a heterogeneous mixture, because it's not uniform. Granite is a type of rock, maybe you studied in middle school, that is a heterogeneous type of rock. It's not uniform throughout. Apple juice, on the other hand, is homogeneous. It's not beer, that's why I put the apple behind it, but it's uniform all the way throughout there. So a solution is a homogeneous mixture. If the stuff's mixed and it's not uniform, why then it's heterogeneous. Now, let's talk about some other things here. I'm not going to ask you about the Tyndall effect, but it has to do with diffraction of light. You'll discuss that in physics. But if you take a solution and you pass a light through it, if it's a true solution, the light will go through, like in the first example. If it's like the second example and light won't go through it, you're actually dealing with a colloid. And you can see the particles bouncing light off there. When the sun sets and it gets real red, that's also the Tyndall effect you're observing, and you're seeing light bounce off those particles. Rubbing alcohol is a mixture of water and alcohol, and they put it in here at a certain percent. It might be 5% or 8% or whatever you want to buy. You can buy a material called witch hazel that's like 90 or 95% isopropyl alcohol. Now, before you get any big ideas, it's been denatured. And what denatured means is they've added poison to it, so that if you were to drink alcohol that you can buy from Walmart without being 21, that stuff can kill you. So please, 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 please do not think you can drink it because it says alcohol. Sometimes when we're 15 or 16 years of age, we sort of think we're indestructible and maybe we make some bad decisions. So please don't do that. All right, so what is a colloid then? Right? We said a colloid is a type of mixture. It's a heterogeneous mixture in that the particles are large enough that they can be seen with the naked eye, so light doesn't pass through this. So some examples of a colloid would be milk. I know it sounds like I say M-E-L-K, that's just the way I say milk. Or fog, or smoke. Those are all examples of colloids. A suspension is a type of mixture where the particles are very large and they will settle down over time. In other words, you have to shake or stir it before serving. If you have freshly made lemonade, it's delicious, right? But you have to stir it right before you serve it, or all the good stuff sinks to the bottom, right? The large particles. Another example of a suspension, maybe when you were in daycare, you kept getting those ear infections from all the sick kids there. So you had to take amoxicillin. It was a little pink bubblegum flavored medicine you take every day. You probably liked it, right? But it says shake well before giving. If you don't shake it, you will either overdose the child or underdose the child, depending on how much stuff is in the dose they're receiving. So suspensions need to be stirred each time. If you make Kool-Aid, does Kool-Aid after it's stirred ever have to be re-shaken or mixed? No. So it's not a suspension. Kool-Aid would be a solution. What about, I don't know, what about something like milk? Do you have to stir that? No. So is it a suspension? No. It's a solution. Can you come up with another example of a suspension? That's a good one. Somebody said muddy water. See, muddy water, if you stir it up and step in it, will look very dark and dirty. And then if you just let it be and don't touch it for 5 minutes, the particulate, the mud, will settle to the bottom and the water will be crystal clear. And that's a mixture. It's a suspension. It's a heterogeneous mixture or a suspension, and it will settle down with time. So let's see how much of this you've actually understood. I have some examples for you to try to classify. So mayonnaise. Now I'll just remind you, they make Hellmann's mayonnaise and they make Miracle Whip that looks kind of like mayonnaise, right? And they're different, aren't they? So it's not an element, and it's not a compound. So it must be a mixture. So is it hetero or homogeneous? What do you think? I'm going to suggest that it's a colloid. They're large particles that don't settle down and don't let light through them, right? Like if you take a mayonnaise jar and you try and light through it, the light doesn't go through the other side and it doesn't settle down. So it's a colloid. What about muddy water? What do you think it is? It's a suspension. Good. And the reason it's a suspension and not a colloid is it will settle down if you stop stirring it, where a colloid will not settle down. What about fog? Fog. If you said colloid, you're correct. Fog just sort of sits there. It doesn't settle down. And then when the sun comes up, the water that's causing the fog changes from a liquid that you can see into a gas that you can no longer see. So fog burns off. Fog doesn't settle to the ground. It doesn't settle out. What about salt water? I hope you said it's a solution, right? Is it hetero or homogeneous? Well, it must be homogeneous because it's a solution. Once salt is dissolved in water, you don't have to keep reshaking it up. Now, why is it a mixture and not a compound? Well, different bodies of water can have different amount of salt in them. The Dead Sea has a very high concentration of salt, so that pretty much anybody can float in the Dead Sea. I believe the Pacific Ocean has quite a bit of salt, and then compared to maybe the Atlantic Ocean, maybe has a little bit less salt. So the fact that you can have a variable composition says that it's not a compound, but instead a mixture. And of course, the other part of that is you can still, in a mixture, the mixture retains the properties of the individual components that make it up. Salt water still tastes salty and still tastes wet. So it retains the properties, so it's not a compound. Compounds do not retain the properties of the elements they're made from. What about oil and vinegar dressing? Italian dressing. That's an easy one, isn't it? That's a suspension. If you shake it up, you got to pour it out right away, because if you wait like 15 seconds, all you have is oil on top and the water went to the bottom. And so you got to shake that stuff pretty well. I know classifying can be a little hard for you. We'll probably take a quiz over that. The best way to do this is just sort of visualize and think about that stuff in your mind. And you can't memorize it, you just kind of got to think about it to make sense. What about Cracker Jacks? What is that? An element, compound, or mixture? Good. It is definitely a mixture. Homogeneous or heterogeneous? It's heterogeneous. Sometimes you get peanuts in there, sometimes you just get the popcorn and caramel, sometimes you get the little prize, right? It's not much of a prize anymore though, it's just a little junky tattoo. You gotta like lick yourself and stick the tattoo on, it falls off right away, and they call that a prize, right? When I was a kid, they gave real diamond rings and that stuff. Nah, I'm just kidding, they didn't. It was junk when I was a kid too. Alright, this one, I found this one in a book. It's okay. You know, it has the most general stuff on the top, and then we have the most ordered on the far left and the least ordered on the far right. So all matter is either homogeneous or heterogeneous. If it's homogeneous, it's either a substance or a homogeneous mixture. Substances are either an element, a single type of atom, or a compound, groups of atoms bonded together. A homogeneous mixture is multiple materials mixed uniformly together. A heterogeneous mixture, the properties are retained, the individual properties, and the substances are not always the same from handful to handful. This is just another one. Again, any of these will do. I'm not going to read everything on there. You can pause it if you think that's better than what I've shown you earlier. And let's pause for just a moment here.